Hello everyone, my name is Swastik Patsarkar and this video is a continuation of previously solved problem on Leetcode, that is two sum, which was done through simple looping, and now we are going to use some optimized version of advanced data structure into the collection framework, that is HashMap. We are going to import the map interface and the hash map class, and then simply create it inside our toSum function. This can be found into the editorial section of the lead code platform, where they have provided it, but still I'm going to type it because it's my practice. Okay, the parameters here given are into the wrapper class format. They have mapped integer key with integer value, which I will name with some different, that is I1. Hash map, open close angular bracket, open close circular bracket. Okay, this is how we have created a map I1. Now the two methods that we are gonna here use is map dot contains key. Here map means the object, that is I1, so in our case scenario it will be I1 dot contains key. So the key should be this temp variable, which is target minus nums of I, that is previously in received number into the array, which we have modified into our hash map. Thing we are going to do is remove this inner for loop, because we do not need, as we have already mapped those values, and we are going to iterate over it ultimately through the hash function. So what the hash function actually is and how does the hash map technique is being used here, we will discuss. Let me comment it. Hash map, this works on the technique called hash function. So what does the hash function does? It takes input, some key value key. It takes input a key. In our case, it would be like index 0 is mapped with some integer value, say 5. So it is going to store at that particular location if it gets the input of key, and it returns the hash code, and that hash code is a unique value. So using this unique value, that is a small integer within the range, say we have created a bucket of array 0 1 2 and so on till 15. So what it does actually and internally working is, it is a combination of our array and linked list. So for every particular hash, an integer value that we have got through hash code, and at that particular address our value will get inserted, like value 5, value 2, and so on. And suppose the has function returns the same hash code. So in that scenario, hash collision occurs. So in that collision, what it does is it applies linked list, creates a chain of linked list here, and let me create a smaller version of linked list. For example, enter two elements. In here we have the last, the head, and the last is null and starting is the head. Okay. So in this format, the linked list is attached to our array indexes. It is quite optimized version than our older for loop version. The important point to be noted here is that in Java 8, from Java 8, binary tree implementation was used to replace these linked lists in case number of linked list get dramatically higher. Okay, gets dramatically higher, then we use binary tree. Binary tree which then reduces the internal recursions and make it to the complexity as big O of 1 plus big O of n, or the size we can say it is slightly higher in number. This makes it quite optimized version than older one. And one thing is that using this, the number of lines of code also get decreases. Let me go to editorial section and make the usual modifications. It has the method called map.contains. It is not map in our case, it is i1.contains key. Our key here is the temporary variable temp that we want to search, and we need to return a new integer format array as map dot get temp comma I. The original index and the key that we want to find into this searching operation, and we are again going to map dot put. We are using map dot put into the new array representation of the two indexed output based on our algorithm, nums of I comma I. Here nums of I is the original index of array, and I is the value we have achieved after applying the hash code. We are again going to convert those values into simpler integer array. because it's our compiler conditioning. Now let me try submitting it. So at what stage it is showing us error? It is 7. Going into editorial section and comparing our program, must remember, okay, this compiler has already loaded with collection frameworks also. We do not need to declare it explicitly, and I had used, okay, let me provide the object we have created for the HashMap I1 everywhere. Okay, the dot put method is given I1 dot put. Okay, yes, now it works fine. Now our code almost meets 99% efficacy compared to our 40% of efficacy on our older version. So this is the magic done by hash function. Great thanks to hash function. Or the map interface into our collection framework. It provides a range of wide data structures into the class format, which we can apply and reduce the time complexity, that is return into our editorial section. What does it say? It reduces time complexity to big of n plus big O of n. Now it becomes big O of time complexity means big O of n plus big O of 1, since it is a combination of linked list and a simpler array bucket. So here's how we can apply the older techniques and improvise our code more profound using predefined libraries and classes into the Java object. So this was implemented through HashMap. So that's it for the day. I will keep learning and doing self review, improving the programming skills. So thank you. Bye bye. Keep coding together.